Okay, so on the back here, now we're multiplying. So remember on the front, you were adding and subtracting, and you needed them to be like radicals in order to add or subtract. And you always added or subtracted the numbers in front and kept the radical piece the same. So now we're multiplying over here. So if you're multiplying something like this, the radicals do not have to be alike, okay? So if you're multiplying this, first of all, the law that you would use would be the distributive law. And you would just multiply these and multiply these. And this is actually a really easy one, so let's do it. So when you multiply these two things, notice one is under a radical and one isn't. So it's just 3 root 2. Okay? And when you multiply these, they're both under radicals. So remember, you can multiply what's underneath the radicals, so it's plus root 10. And that's the final answer. You cannot add those together because they're not alike. So you just leave it. Okay, so similar idea here. I think maybe we'll just do the same thing and verify one of these on the calculator. So this one, you would get 3 root 7. The reason why that works that way is because that's not under the radical and that is. Minus, these are both under radicals, so you can multiply them together, root 49. But that simplifies, so you get 3 root 7. The square root of 49 is 7. Should we verify that one? Let's verify that one. Okay, so let's look. So root 7 times 3 minus root 7. Okay, so here's what it looks like. There's the answer, and we got 3 root 7 minus 7. Okay, so there's what we got as the answer. Here was the problem. There's the answer. Here was the answer. Let's see what there we go. So they're the same. So it's verified. Okay, so next one. When you multiply these, you can multiply what's outside the radicals and what's inside the radicals. So 4 root 6. There's an implied 1 there, so 4 times 1. And then here you can multiply what's outside, what's inside. So 4 root 10. And you might want to ask yourself in the end, like, can that be simplified? Can that be simplified? Neither of them can be simplified because they don't have factors that are perfect squares. Like that's just 2 times 3 and this is just 2 times 5, and none of those is a perfect square. Aha, so this is a binomial times a binomial. So how do you do that? Okay, it's very similar to how you do this. Okay, you FOIL. Okay, it's a binomial times a binomial. 2 terms, 2 terms. Remember, the terms are separated by the pluses and minuses. So here we go. First, 25. Outers, 5 root 6. Inners, minus 5 root 6. And last, negative root 36. You can multiply what's under there. All right, so let's see. Simplify. These will actually cancel each other out because they're plus and minus the same term. And this is 6. So it's 25 minus 6. It's the square root of 36, and that's 6. So the answer here, 19. And if you want, you could verify that on the calculator. Another FOIL. Binomial times a binomial. So that's how I know I'm foiling. Here we go. First, 6. That's a nice one. Outers, minus 6 root 5. Inners, plus 3 root 5. Remember, it looks like that because that's not under the radical, and that is. And then the last are minus 3 root 25. Okay, you can multiply what's underneath the radical. So you get 6. Combine those. It's negative 3 root 5. And then this is 3 times 5. So it's minus 15. And now combine those. 6 and negative 15, negative 9. That's it. These are good problems. There's another FOIL coming. So let's see. First, 4 root 9. Multiply what's outside the radicals, multiply what's inside the radicals. Minus 20 root 6. Multiply what's outside, multiply what's inside. Inners plus root 6. And then last, minus 5 root 4. Okay, so simplify. This is 4 times 3. Combine those, it's negative 20 plus 1. So it's negative 19 root 6. And then this is minus 5 times 2. So it's 12 minus 19 root 6 minus 10. So it's 2 minus 19 root 6. And then the last one. If you're doing something squared, this is really important. It means you write it twice and multiply it and not something else. You need to write it twice and FOIL. Squared means write it twice and multiply. So here we go. First, 16. Outers, 4 root 7 minus 4 root 7. Inners, minus 4 root 7. Last, positive, because it's a negative times a negative, root 49. And I'm sure you can see what's happening here. Combine those, it's negative 8 root 7. This is 16, that's 7. So 23 minus 8 root 7. Should we check this one on the calculator? Let's do it. Okay, so there's the original problem. And then we got 23 minus 8 root 7. Oops. Is it the same? Yes. Okay, and then lastly, we're rationalizing again. But if you notice these, when you rationalize, these each have 2 terms. And so this is a special type of rationalizing the denominator. Remember, we did do rationalizing already, and it was when you ended up with answers like this. We multiplied numerator and denominator by root 2. And what ends up happening is you get rid of the radical. So the answer would be 3 root 2 over root 4, which is 3 root 2 over 2. Okay? But remember, the ultimate goal is to not have a radical in the denominator. So when you're rationalizing and it has more than one term in the denominator, you use what's called the conjugate. And the conjugate is you just change the sign between the 2 terms. So the conjugate of this thing is root 3 minus 2. So this is asking, are there any conjugates in problems 9 through 14? So there were conjugates on 11. Look, because it's the same exact thing, it's just different signs. These are called conjugates. You just change the sign in between the 2 terms. What happens when you multiplied them? You ended up with something that did not have a radical in at all. And that's what you want your goal to be here. So that's why you use the conjugate, because when you multiply by the conjugate, it always gets rid of the radicals. So here you would be multiplying by the conjugate. You're using the conjugate because there's more than one term here. There's 2 terms in the denominator. So the conjugate would be 4 plus root 7. It's just changing the sign that's there. Ah, come on. Let me write this out in the numerator before. Actually, let me write out both of these. In the numerator, it's going to be this. It's a distribution. Okay? This is really important. It's a distribution here. And then in the denominator, it's going to be 4 minus root 7 times 4 plus root 7. And that's a FOIL. Okay? So that's what you're going to be doing. And you have to actually multiply these. So numerator, easy, easy. 12 plus 3 root 7. Check me. Denominator, you have to FOIL. So here we go. 16 for the first term, 4 times 4. Outers, 4 root 7. Inners, minus 4 root 7. So that's those two. And the last are minus, because it's a negative times a positive, root 49. Okay, so write all these down and let's go for the simplifying. So these will cancel each other out. This is just minus 7. So you end up getting, because the square root of 49 is 7, 16 minus 7. So it's 9 in the denominator. And then you could actually break this up into this over this and this over this and simplify, because I could see that these all have a common factor of 3. So 12 over 9 plus 3 root 7 over 9. So that's 4/3. This is 1/3. You can have the 1 there or not. You could write it all over 1 if you want to do 4 plus root 7 all over 3. You can write that as well. So should we verify it on the calculator? Sure. Okay, let's do the stackable fraction. So original problem. So there's your original problem. I used the stackable fraction. So what answer did we get? We got 4 plus root 7 all over 3. And it's the same answer. So we did it correctly. Okay, last one. Okay, so multiply by the conjugate. So what does the conjugate look like in this case? It's 1 minus root 3. So, and remember, you're multiplying by the same thing over the same thing. So this is just your funky form of 1. Okay, in the numerator, it's a distribution. In the denominator, it's a FOIL. So you get 4 minus 4 root 3 in the numerator. Okay, I just multiply those, okay? Remember, it's just 4 root 3 because that's not under a radical, and that is. Denominator, first 1. Outers and inners are root 3 and negative root 3, okay? So remember, first, outers are actually negative root 3, inners are positive root 3. Last are negative, because it's a positive times a negative, root 9. Okay, so I'm going to come down here. This is minus. So it's 4 minus 4 root 3 over these cancel each other out because they're plus and minus the same term. So it's 1 minus 3. So it's negative 2. All right, so this is another case where you will simplify because of those 3. So split it up into 4 over negative 2 minus 4 root 3 over negative 2. Okay, I just split up into this over this and this over this. So this is negative 2. And this becomes positive because it's negative 4 divided by negative 2. So plus 2 root 3. And it's because these give you 2. You could check that one on the calculator if you want. I'm sure it's correct. Take care, everybody.